You make this amazing sculpt.
Yeah, something you're really proud of.
But it's technically useless for dynamic stuff. It's just a dense mess of faces. So then you're facing
Beautiful, high res, super detailed.
millions of polygons.
Right. And then you try to actually use it like in a game engine or for animation.
Yeah.
That's where the fun stops.
The pain begins.
Our sources, they keep hammering this point home. It's kind of depressing, actually, the traditional way.
Manual retopology, texture baking.
Yeah, that can take anywhere from, get this, 14 to 40 hours for one asset.
That's the hidden cost, isn't it? The sheer time sink in the 3D pipeline.
Yeah.
You make this amazing sculpt.
Yeah, something you're really proud of.
But it's technically useless for dynamic stuff. It's just a dense mess of faces. So then you're facing days, literally days of just drawing squares.
Drawing quads, yeah.
Struggling with weird geometry, like n-gons, triangles showing up where you don't want them.
And then you hit baking. Oh, boy.
The baking nightmare. Visible seams, along the UV edges.
Always the seams.
They haunt you. And it's just such a technical headache.
It really is a productivity killer. It feels like you're just doing cleanup forever just to make your art usable.
Totally.
But that's our mission today. We're doing a deep dive into two specific tools. QuadriFlow, clean, and texture bake with Cage.
Right, used together as a system.
Exactly, a unified pipeline that completely automates this whole cleanup process. And the claim is, well, it's pretty astonishing. A 99% plus time saving.
It sounds almost too good to be true, but the breakdown makes sense.
Reducing potentially 40 hours of work down to maybe 2 to 8 minutes.
That's the target.
Yeah.
And what's interesting is it's not some brand new magical algorithm out of nowhere.
Okay.
It's more like an intelligent automation layer built on top of powerful core Blender features like the QuadriFlow algorithm, which is already there.
So it's leveraging what Blender already does well.
Exactly. These add-ons just handle all the tedious setup, the error checking, the cleanup, all the stuff that used to just steal days from artists.
Okay, let's start with that first bottleneck, the one everyone seems to hate the most, retopology. For anyone listening who's maybe newer to this, can you just quickly explain why manual retopology is such agony, and why does messy topology mess up a model?
Sure. Well, it's agonizing because you're essentially fighting the geometry. When you sculpt, you're focused on the look, the shape, the details, right? Not how the polygons connect.
You're just pushing and pulling digital clay.
Exactly. But game engines, animation software, they need clean geometry, mostly quads, four-sided faces. If you have faces with 5 or more sides, n-gons, or too many triangles in the wrong places,
Things break.
things break. Shading gets weird. And if you try to animate it, like bend an arm, you get these awful pinching artifacts or weird stretching where the mesh should deform smoothly. The math just doesn't work right.
Got it. So QuadriFlow is meant to be the cure for that specific pain.
Pretty much. One click, it takes any high poly sculpt or even messy imported geometry and converts it into clean, production-ready quad topology.
Okay, but hang on. You mentioned Blender already has tools like QuadriFlow, so why the add-on? What's the extra sauce?
That's the key difference. The built-in tool is powerful, yes, but it can be, let's say, fragile. If the mesh you feed it isn't perfect, it can just fail or give you bad results. QuadriFlow isn't just running the algorithm, it's wrapping it in automated steps, before and after. Think of it like 3 pillars of automation that make it reliable.
Okay, pillar 1.
Pillar 1 is mesh repair. Before it even tries to remesh, the add-on automatically scans your input mesh.
Finds the problems.
Finds the common problems, yeah. Loose vertices floating in space, faces with 0 area, duplicate bits of geometry, things that often trip up the core remesher, especially on imported models.
So it cleans the input automatically. That alone must save time hunting for tiny errors.
Oh, absolutely, hours sometimes. Pillar 2 is conforming. So after QuadriFlow creates the new clean quad mesh,
Which is usually much lower poly count.
right, much lower, but you need it to match the shape of your original high detail sculpt. So it automatically adds a shrink wrap modifier.
Okay, so it shrink wraps the new mesh onto the old one.
Exactly. It conforms the low poly structure perfectly back to the high poly surface details. So you keep all that visual fidelity you sculpted.
And the source material mentioned 2 ways it does this conforming. Why 2 methods?
Good catch. Yeah, because different types of models need slightly different approaches. For organic stuff, characters, creatures, cloth, you generally use the nearest surface point method. It lets the quads flow nicely around curves.
Makes sense for smooth shapes.
But for hard surface models, robots, weapons, vehicles, you often want really sharp edges and flat planes.
You don't want those softened.
Exactly. So for those, you switch to project, all axes. It's better at preserving those crisp lines during the shrink wrapping. Using the wrong one can make organic stuff look blocky or hard surfaces look mushy.
That's a really useful distinction. Okay, pillar 3.
Pillar 3 is crucial for the final look. Smart shading. You can have perfect quad topology.
But it can still look kind of faceted, right? Like you can see the individual polygons.
Precisely. Especially on curved surfaces. This happens because the surface normals, basically, the direction each face is pointing for lighting, aren't smoothed properly.
Okay.
So the add-on automatically applies the weighted normal modifier. This is a fantastic tool. It intelligently averages the normals across the surface.
So it tells the light how to react smoothly.
You got it. It tells the rendering engine, hey, treat this surface as smooth, even though it's made of flat polygons. It gets rid of that faceted look without adding tons more geometry. It's essential for production quality.
So for you, the user, the main thing you need to decide here seems to be the target faces setting.
Yeah, that's your main control knob for this stage. How dense do you want the final quad mesh to be?
And that depends on what you're using the asset for.
Totally. The sources give good guidelines. For like low poly game assets, maybe background props or stuff for mobile, aim for around 5,000 to 10,000 faces.
Okay.
But if it's a main character, something that needs to deform well for animation or appear in close-ups, you'll want more detail. So maybe 15,000 to 30,000 faces. That preserves more shape and gives better deformation.
All right, so Quadify handles the topology nightmare. We've got a clean, low poly mesh with the right density. But that brings us to hurdle number 2.
Which many artists find even more frustrating.
Texture baking. The stuff with legends, mostly bad ones.
Yeah. The traditional process. It's rough.
You hear about the visible seams all the time, where the UV islands meet and the texture just doesn't line
The
up.
bane of bakers everywhere.
And those weird black texture bakes you get sometimes, especially with imported models.
Yeah, where the material information gets lost or something goes wrong with the bake casting. And don't forget, manually building a bake cage.
Right, the cage. Explain that quickly. Why do you even need a cage traditionally?
Okay, so baking works by casting rays from your low poly mesh out to capture details from the high poly mesh, right?
Like sampling the surface details?
Exactly. But near the edges of your UV islands, those rays can sometimes miss the high poly surface slightly, or they shoot out and hit the wrong part of the high poly model on the other side.
Ah, so the ray goes astray at the seams?
Precisely. And that causes the mismatch, the visible seam line in your baked texture. The traditional fix was to manually model a slightly larger version of your low poly mesh, the cage, to contain and guide those rays accurately.
Which sounds fiddly.
Incredibly fiddly and error-prone. Getting it just right took ages. This is where Texture Bake with Cage comes in. Its core innovation is automated cage-based baking.
Okay, automated cage. How does that work?
It just generates the cage for you, instantly. When you enable the Use Cage option, it looks at the size of your low poly target mesh, its bounding box.
Its overall dimensions.
Yeah, and it creates a cage that's slightly inflated, usually by a tiny calculated percentage, like 0.05% to maybe 2% bigger.
So it's automatically sized.
Perfectly sized and adaptive. This cage acts like a buffer, ensuring the rays always hit the correct part of the high poly surface, even right at the UV seams. It handles all the complex ray direction stuff automatically.
And that's how they can claim 0 seam artifacts guaranteed, because the automated cage prevents the rays from missing.
That's the principle, yes. It removes the major source of human error in cage creation, which is where most seam problems originate. It's robust enough for complex shapes because it's a consistent calculated offset. You check the box, the problem is solved.
Wow, okay. That alone is huge. What else does it do for production quality?
2 other big things stand out. First is 2xSAA, super sample anti-aliasing.
Fancy name. What's it do?
When you turn that on, it actually bakes the texture at double the resolution you asked for. So if you want a 4K texture,
It bakes at 8K.
it bakes at 8K internally. Then it intelligently downsamples that 8K bake back down to your target 4K.
Why do that?
Anti-aliasing. Smoothing. It results in incredibly smooth edges in your texture map. Think about fine details or where different materials meet. It gets rid of jagged pixelated lines. Much higher quality.
Is there a catch? Faster usually means lower quality, so slower must mean.
Yeah, there's a trade-off. It takes about 4 times longer to bake with 2x SSAA enabled because it's processing 4 times the pixels, right? 8K is 4 times the data of 4K.
Okay, so it's slower, but the quality boost is significant.
Definitely. For a final asset, especially something important, it's almost always worth the extra bake time.
Makes sense. And the second quality enhancement, you mentioned fixing black textures.
Right. That often happens if your original high poly sculpt uses an emission shader. for parts that glow or emit light.
Like lights on a spaceship or glowing eyes.
Exactly. Standard baking setups can misinterpret those emissive materials and just render them as black. This add-on has smart detection, specifically auto EMIT detection,
So it sees the emission material.
and automatically switches the internal bake mode to handle it correctly. It prevents those black texture results just by being aware of the source material type.
Clever. Okay, one more feature that sounds amazing. The auto prepare recommended button? Sounds like a magic button.
It kind of is. You select your clean, low-poly mesh, the one from QuadriFlow, you click this button, and bam.
Bam! What does BAM do?
It does like 5 or 6 manual steps instantly. It clears any leftover sharp edges or seams from the retopology stage. It runs Blender's Smart UV project to give you a decent starting unwrap automatically.
Okay, UV's done.
It sets up the basic material nodes on your target mesh so it's ready to receive the baked texture. And crucially, it makes sure the texture being created is a 32-bit float texture.
Okay, hold on. 32-bit float, why is that important? Sounds technical.
It is technical, but really important for quality. Standard image formats like 8-bit JPEGs or PNGs can only store a limited range of brightness values.
Right.
If your baked texture has really bright highlights or really dark shadows, an 8-bit texture clips that data, it cuts it off, which can lead to visible banding or loss of detail in extreme lighting.
Like stepping in gradients instead of a smooth transition.
Exactly. A 32-bit float texture stores a much wider range of values. Full, high dynamic range, HDR. It preserves all the detail from the brightest brights to the darkest darks. No clipping, no banding. It's what you need for modern rendering pipelines and realistic lighting.
And this button sets that up automatically.
Yep, saves you from forgetting or having to manually configure the texture settings later. Ensures professional-grade output from the start.
Okay, this is where it all comes together then. The synergy between the two tools. Quick Quadify makes the perfect target mesh.
Clean quads, right density, conformed shape.
And Texture Bake uses the original high poly as the source and bakes onto that perfect target with the cage and quality settings handled.
Exactly. It becomes this seamless pipeline. Quadify output feeds directly into Texture Bake input. No awkward steps in between.
It really does sound like it transforms the whole workflow.
It takes what used to be this fragmented, multi-day, often multi-software headache,
Yeah, jumping between programs.
and makes it a single, streamlined process inside Blender.
So let's walk through it one more time, super quick, using that character example. Start. High poly sculpt, maybe 500K, a million faces.
Okay.
Super detailed.
Okay. Step 1, Quadify. Select a sculpt. Run Quick Quadify. Set target faces to, say, 25,000 for a decent character. Click the button.
And it does the repair, remesh, conform.
All automatic. Takes maybe 30 seconds to 2 minutes, depending on complexity. Boom, you have character QEA.
Nice. Step 2, prepare. Select character QA, go to the texture bake panel, click auto prepare.
Instantly done. UV's created, material set up, 32-bit float ready.
Okay. Step 3, configure bake. Make sure your original high poly sculpt, the source, is visible. Select the source first, then shift, plus click the target, character QA it.
The order matters there. Source, then target.
Got it. Then in the texture bake panel, check the boxes for use cage and 2S, SSA. For max quality, 0 seams.
Yep, set your desired resolution too, like 4K.
Right. Step 4, bake. Hit the big full bake texture button.
And grab a quick coffee. Depending on the resolution and SSAA, it might take a few minutes, maybe 5 to 8 minutes for a complex 4K bake with super sampling.
Still, minutes, not days.
Exactly. And the result, a fully optimized, production-ready character, clean topology, perfectly baked normal map, maybe others like ambient occlusion, all done. Start to finish, maybe 5 to 10 minutes total.
That's insane compared to the old way. Retopology, 10-30 hours versus less than 2 minutes.
Fixing seams and cage setup, 5 hours versus 0, it just evaporates.
It's genuinely a 99% plus time saving on those specific tasks. It's hard to even grasp that level of acceleration.
It's a fundamental shift.
Yeah.
So, yeah, if we just summarize the value here, it's about getting that professional, quality, consistent topology, no seams, but achieving it with, well, almost unbelievable speed.
Quality and speed, the holy grail.
It really impacts the economics of asset creation. For studios, for freelancers, it changes how much you can produce, how fast you can deliver.
Okay, now here's where my mind goes, thinking about the creative side. The source material hints at something interesting because Quadrify is so fast.
Right, the target faces setting.
Yeah, you can change that number easily. It implies you could use this to rapidly generate multiple levels of detail LODs for one asset, like a 30K version, a 10K, a 5K.
Absolutely. Run Quadrify multiple times with different target counts. Takes minutes per LOD.
So think about that for you listening. If making one high-quality, game-ready, animation-ready asset goes from taking days down to just minutes, how does that change your actual design process?
Does it mean you just make more stuff?
Or do you iterate more? Do you try out wilder ideas because the cost of technical cleanup is suddenly almost zero? Can you build way more complex scenes because prototyping and refining is so fast?
That's the really profound implication, I think, when you remove that massive time barrier of manual labor.
The bottleneck just disappears.
Yeah. The long-term advantage isn't just speed. It's the freedom it gives you. The freedom to experiment, to refine, to push creative boundaries without worrying about spending the next 3 days cleaning it up.
What new possibilities open up when making it work takes minutes, not days? That rapid iteration potential, that's something to really think about.
Definitely something to mull over.
Okay, good to know there's flexibility. And just to double check for anyone who's been pulling their hair out over those black textures from imported models, does the add-on specifically fix that GLB-OBJ issue?
It does, yes. The documentation confirms that there's specific code in there designed to tackle that exact problem. It basically forces Blender to load any external textures linked in the GLB or OBJ file into the GPU memory before it even thinks about starting the bake. So yeah, that particular frustration should be gone.
Yeah. That's fantastic news for a lot of people, I'm sure. Okay, let's put it all together. Walk us through the quick start. If I've got my high poly source model ready and my low poly target model ready, what are the actual steps using this add-on?
It really boils down to 3 main steps. Super streamlined. Step 1, prepare target. Just select your low poly mesh, the one you're baking to, and click that auto prepare button. Done. UVs, material, texture node, all set up.
Okay, step 1, click the button. Step 2.
Step 2, configure settings. Find the bake panel for the add-on. Here you'll set your texture resolution, maybe 2048 for general stuff, 496 if you need high detail. Crucially, make sure use cage is checked. It should be by default, but double check. That's your scene prevention. And then for final quality, you'll want to enable 2x SAA.
All right, prepare, configure quality. And step 3, the main event.
Step 3, bake. This is the selection order bit. First, click your source model, the high poly one. Then, and this is important, hold shift and click your target model, the low poly one. The target needs to be the active object, the one with the brighter orange outline in Blender. Once you've got that selection right source first, then shift click target, just hit the big So Bake texture button. That's it. The add-on takes over from there.
Okay, that does sound simple. Now in those settings from step 2, there were a couple of other options. Margin PX and max ray distance. If the cage is automatic, why would we ever need to touch those?
Good point. Mostly you won't. The defaults are pretty smart, but it's good to know what they do just in case. Margin PX is about pixel bleed. It adds a border of pixels around each UV island in the baked texture. Default is 16 pixels. If for some reason you still see tiny seam lines even with the cage, or if your UV islands are packed super tightly, bumping this up to 32 pixels can help. It gives game engines more room for MIP mapping without issues too.
Okay, so margin is like a safety buffer. What about max ray distance?
Max ray distance tells Blender how far the projection ray should travel from the cage to find the source mesh surface. Because the automated cage is generated really close to the source, the default value of 0.1 is almost always fine. You'd really only need to increase this if, for some unusual reason, your high poly and low poly meshes were physically quite far apart in the scene. But for the standard workflow, just leave it.
Gotcha. Defaults are usually best unless something looks wrong.